welcome back. This is Lee from Starlia, and following last night's design discussion with AI, today we're going to dive deeper into the actual design and some coding part. So first, the setup, Xcode, the terminal we'll use, and for now I put the Cloud UI on the left because token is important, and I believe I'm already out of token because for Fable they reset it. That's weird, because last night I was pretty sure my Fable usage was 50%. It seems they reset it somehow. I think we're lucky. Yeah, so that means we can still use it. So the right hand side is still the terminal from yesterday. I didn't even close the session. One thing is you can press Shift plus Tab to shift between different modes, plain mode, auto mode, default. So if you want to ensure it's read-only, so it doesn't write any file without your permission, you can switch to the plain mode. That's pretty handy. I will keep the context, but let's check the usage. So /context will tell me how much context we have. For now, it's mostly messages 100,000. For this size, you can continue, but because I'm tied on token, I will just use /compact. It will take a while to shrink the context, and you will spend some tokens. So you will see the current session jumping to maybe 4%. That's my guess. But I think that's worth it. Oh my god, 7%. It should be much less. So I have a feeling that Fable is increasingly becoming more expensive. Like the same computational task will cost more and more tokens on a daily basis. So I don't know. I want to choose to trust Cloud, but that's just my intuition. My objective observation tells me that the same task is costing more tokens day by day, but we'll see. And the current trial, the Fable trial, will end on July the 12th. So including today, we'll have 4 more days. After that, we'll have to use the the Cloud API to access Fable, and that will be much more expensive. So I haven't decided my mind yet, and my theory is do not over plan for the future. So in 4 days we will see. 66%. While it's compressing the memory, the context, let me describe our context a little more, right? So Starlia, we are a startup to combine the best part of modern technology with awareness system. All these traditional wisdom we get from mindfulness and from various kinds of religions and non-religions, and the specific goal for this app we're building is to help people realize their short-term emotion and help them return to their center. Because many times what we found is many people, when they are angry or exhausted or depressed because of the short-term event, they are not aware of it, so they carry this emotion on for many hours or even days without realizing it. So as a result, they suffer a lot unnecessary time. So the theory is, if we can make a product or device that automatically detect the internal state by looking at all these physiological signals and infer the user's internal knowledge, the internal emotion, then we can give them a gentle nudge and walk them through a very brief, gentle breathing exercise or any mindfulness meditation exercise. And then they will come back to their center. They will feel calmer. And that can be measured by the biometrics. We cannot fake it, right? So if after the exercise their heart rate drops, their breathing drops, then we know it works. And of course, on this cycle, we can do some survey, right? We can ask the user, hey, like, how do you feel now? Like, I detected your heart rate jumps in the past few seconds. So how do you feel now? Do you feel angry or do you feel depressed? And all these are depicted as emojis. So they don't need to type or talk or anything. They just pick an emoji to label their current emotion. And then after the intervention, we have another survey. They can tell us how they feel. Like, do you feel better or worse or the same after the exercise? Then we have all the signals to improve the system to learn. And then hopefully this can help people to have more realization or more awareness of their current state and reduce their suffering of the short-term short-term tempers. Cool. So the compression is done, and we can double check the context map. Yes. So this is the default. So only 4 silos, 4 disks, 4 purple disks for the memory of the messages. So 20,000 tokens on that is normal. All right. So back to the specific task we were tackling. We have 7 states or 7 emojis that we detect. And for now, we have 2 signals. One is the heart rate. One is the core motion, or in general motion. And based on the heart rate and motion, our system will detect if the user is in some kind of short-term emotion, and then we will send them a nudge. And then once they are nudged, they can pick, like, how do you feel? 1 out of the 7 emojis. So if they pick the smiling face, which means they're fine, if they're fine, then it's a false positive. Then we'll just stop. We'll say, okay, great, enjoy, take care, and then we exit. However, if they do have some real feelings like anxiety or depression or sadness or even excitement, sometimes when we play games, like, we get overly excited and our heart rate will jump. So we detect that. Then we follow with a brief breathing exercise, very short, 1 minute. And after that, we do a post-intervention survey to ask the user, hey, do you feel better now? And then we end it with a quote. So it might be a little boring to hear me describe it, and the best way to try it is to download our app from TestFlight. So we're not on Apple Store yet, but we are available. We do have our initial bundle available on the TestFlight. So if you're interested, you can DM me and I will send you an invitation code. All right, so what's the problem? The problem specifically is the current core motion API from watchOS is extremely delayed and it's not very accurate. Why that is a problem? Because if the motion signal is delayed by 10 seconds or 20 seconds, then by the time we detect the heart rate spike, we will also check the notion signal. If the notion says the user is moving intensively, then we'll think, oh, this might be a false positive. So we don't need to follow. We don't need to nudge, because it's natural. Like when you're running, when you're weightlifting, like your heart rate will spike. So that is not a short-term emotion. Like what we're more interested is the stationary case. Like while my body is not moving, but if I'm under a lot of stress or in a very tough conversation that triggered me, then my internal state will rise. Like we'll have the arousal, and then my heart rate will spike. So that's the case we want to capture. So the motion sensor is a very important gate for us to focus on the stationary emotion versus the natural heart rate spike from intense physical exercises. That's why it's important. If it's delayed, then the motion gate is not accurate, so it will affect our precision, right? So a concrete example, say that my heart rate spike for 20 BPM, and it's mainly because I was standing up to go to the toilet, and my body has a sudden switch from a stationary state to a fast walking state. That's why my heart rate spikes. Ideally, we shouldn't nudge this, because this is not a short-term emotion scenario that we want to address. But if the motion sensor is delayed and the motion only sees 10 seconds ago, I say, oh, like this guy is stationary, so he's sitting still and he's having a heart rate spike, so that is some internal state change and we should track and nudge him. Then it's a false positive. Then we should fix it. Okay, so that's why we're doing this. Yesterday we discussed a lot about the product side, like what's the positioning of the product, especially how we define the true positive, like really what kind of scenarios we want to capture and notify, and which scenario we do not. I think it's pretty clear. We have a table generated. Let me see, where is that table? Here. Yes, it's right here. So it's a table of HR peaks scenarios. I believe these are 13. Very concrete examples, and the values for detection and intervention. And then the verdict is should we notify or not, plus the current slots, right? So in the current UI design, we have 7 slots for emojis, and under which slots each scenario falls into. So this is very complete, and the only 4 rows where we don't have a current mapping, these are low value or low to mid value in both detection and intervention, so the verdict is to silence them or to drop them anyway. So we are largely aligned. The only potential deviation is, so all these 13 scenarios, they map to 5 or 6 emojis, but on the current dial, we do have another emoji, which is the running one. Yeah, so tired and running. So we had this running one for the exact same reason. So previously, when I was trying this on my own demo, when I suddenly stood up, or when I was walking up and down stairs, my heart rate will surge, and then the watch will notify me, and this is the emoji I would pick, because it's not a short-term temper, it's more like a physical thing, right? So that's why we had this. And according to the new direction we're going, we should drop this, right? Because this is not a short-term emotion. So let me clarify this really quick with AI, because they should have the context. Again, so I'm using WhisperFlow. So following yesterday's discussion, there is one scenario I want to deep dive. So if I was sitting for a long time and I suddenly stood up to go to the toilet or run down the stairs to get something from the fridge, my heart rate will spike. But I might not have a strong short-term emotion that can be clearly classified as anger or anxiety. So does that fall into our product's scope? Is that something we want to capture, or we want to drop completely? This is a question where the AI had some inconsistency answering. I believe in yesterday's session, at some point it said we should just drop it. Like, this is not our target users, target use cases. But at the end, it's still keeping this in the 7 emoji picker, the dial. So I want to clarify. This is important because if we don't want to track it, we should drop the emoji completely, and we should replace that with another. The data scope, yes, unconditionally, and it already is. Every return sample is logged in every phase. Oh, I think in the IMU, the stream writes alongside it. Suppression in our design only ever means no haptics. Yes, data side, of course we track it. We do have it. Alarm scope, drop it deliberately. Notify if the HR rise is unexplained by observable context. Product scope is in scope, but not through this door. Posture transition almost always carries a real internal state shift. That unnamed flicker of fatigue or arousal you described, which English barely has a word for. That's a legitimate interoception product, but its value is reflection, not relief. And it's roughly periodic and predictable. Okay, I agree. We should drop it from nudging. So if we detect that that scenario, we do not nudge. What do we do with the emoji picker? Do we still want to keep this running emoji? And if we do, what's the use case? Like in which scenarios will the user actually tap on it? Sometimes Whisperflow will translate to Chinese. That's very annoying, and I don't know how to fix it. Okay, I agree that we should drop it from nudging. But how about the emoji picker, the running emoji? Do we want to keep it or drop it? If we keep it, what's the actual use case that the user will actually tap on it? Keep it, but recognize that the gate changes its job. Today is mostly a false positive annotation. It's mostly a false positive annotation button. The nudge fires on something that IMU should have caught. So it's saying after we fix the IMU sensor gate, the previous entry will be a false positive and mostly be dropped. However, AI said we still want to keep this for 3 reasons. So it's a physical calm down from exertion. For that reason, we want to keep it. Sensor blind physical arousal with no exertion at all. Like a hot shower, hot room. But then I wouldn't pick this emoji. It will be very hard for the user to link a hot shower, hot room to running emoji. Data purity for every other label. So I mostly agree. Like for the original case, like a sudden stand-up case, we shouldn't nudge. So that we are aligned. So 2 questions here. One is, if we do keep this running emoji, and for a second scenario, if it's like post arousal, actually the second case is the sensor blind physical arousal, like a hot shower or a hot room. In this case, I do agree we can nudge, but is running emoji the right emoji? And my second question is, in this case, do we still want to intervene, or will it be more meaningful to keep this emoji as a manual entry only? Like the user can click these two. So I think two options, right? One is, there are three options in fact. So first we can keep this running emoji and keep the intervention just as today. That's it. So no change. Option 2 is we keep the running emoji and we remove the intervention, so it becomes acknowledge, the same as this smiling face. The third, or the other dimension, is we change it to something else, something completely different. I didn't frame my question very well. So the orthogonal question is about manual trigger versus auto detection. With all these discussion, all these new scenarios, do you feel, or would you think this running emoji entrance is more for auto detection or for manual trigger, and why? Sometimes it will translate to Chinese, transcribe to Chinese, and sometimes it comes back to English, and it translates my running emoji, the word, to the actual running emoji, but a different guy, like this guy is in red shirt, which is very interesting. I myself need some breathing exercise. I didn't eat my breakfast because lunch is very soon, so maybe my brain is not working properly. Apology for that. This is an auto detection starts, almost purely. In an auto detection episode, the label explains like what causes the spike. In the manual episode, the label is an intent. They don't tap because they want the moment. Sensor building physical arousal. The problem with the running becomes precise. It names an activity, but the picker asks about a felt state. Change the glyph to this hot or flushed face. This is the funny part, because this emoji has a lot of implicit relationship to sexual arousal, as far as I know. Maybe that is a new use case we didn't explore. A physical string, like a long tail after the exercise from the gym for a while, my body still feels uplifted. So if we detect that, we want to interfere, and the mindfulness breathing can calm them down. So that is a legit use case. And the true running case, like I am running, or I am fast walking from my seat to the toilet to the refuge, those will be cancelled. In the new world, those will be false positive because the motion sensor will capture those. In general, I like the transition from activity to feeling. That will make the whole thing much more consistent, because all the dials, all the emojis we currently on the hex layout dial is for facial expression, like how the person feels. The running one was an outlier because it was precisely for the suddenly stand up and run into the toilet case. And that case, according to the new agreement, is a false positive and will be captured after we change the motion sensor and add a sensor gate from the IMU. So that case can be dropped. And the new case is, as we discussed, the long tail excitement from post-exercise or the hot room and hot shower. Those can be captured by a facial expression emoji. So I agree, we should replace the running emoji with something else and drop the physical sudden spike use case altogether. So we focus on the long tail and the insensible arousal. So that's the direction. You have my consensus. On the specific choice of this emoji, I want to discuss, because this emoji has a very strong connection to sexual arousal in certain communities. So if you check online, you might find more about this emoji. What are the other candidates? After your research, do you insist this is still the best choice, or you have better proposal? Yeah, so mostly aligned. Just do some careful survey on the current hot or flushed face emoji and propose any candidates. I'm sorry, I think I lied again. So I promised to dive into the design and coding, but again, spend quite some time on the product. I think it's worth it. You will see what I mean, because the worst thing we want to see is we dive into the system architecture design for 3 hours, then we realize, oh, like, the product positioning is wrong. Then we come back to the top level and everything has to be rewritten. So it's best to have the product right, and then the system, and then the coding. Oh, I need to check my token usage. 30%. They definitely increased the spend rate. It shouldn't be that much. Anyway, I like this melting one. It's so cute. Yeah, and it carries a lot of meanings to it. Like it's slightly smiling, but it's dissolving. Like it has a very strong connection to like a hot room or a hot shower. Emotion wise, I might be fine, but physically, uh, could be at my limit. Face exhaling. So my instinct is right, and the AI is dropping the proposal. Is a sling center of gravity is thirsty, uh, reacting someone's physical attractiveness. So it appears on curated, not suitable for work emoji lists, not just weather threads. Um, healthy products checking dial, that's a disqualifying. Yeah, younger testers get a sneaker moment, and the deeper problem, the emoji's self-description reading is contaminated. Yeah, so if we were to release a sibling product, especially for the teens or for dating purposes, or like emoji watcher during date, then this is a good candidate. But in general, that's out. Here's how the candidates come out. Melting face, considered and rejected. The literal heat mapping fits, but its dominant usage is emotional embarrassment. Oh, interesting, I didn't know that. Feeling overwhelmed, I can see, dread, barely holding it together. My body, not my mind. This is rejected for sure. Yeah, so face exhaling is the right call. Okay, so now is the design phase. We'll have a small design and coding task to just swap. In fact, there's no design for this. You just swap it. Okay, let's replace the current running emoji with your new proposal, the face exhaling emoji, and then we update all the docs. And I switched the mode from plan to auto mode down, so the AI has all the permission to update the files. And remember the privacy concern because I'm streaming, so do not show any code, no code snippets. You can use some natural language to describe what is the blocker, how you resolve it, so we can learn together, but no explicit code anywhere, and carve that in your memory throughout the session. I believe it has the memory because I'm in the same session from yesterday, just to be safe. And meanwhile, check my usage. 32%. In the afternoon, I need to go out, have a meeting, so I will have lunch soon. Guess I will do another 30 minutes. Hopefully we can finish the whole task, and if not, we will leave it to the next session. Meanwhile, some mindfulness time would be great. I feel it's printing something. I believe the code is done, and now it's updating the markdown files. How much token? 38. Basically, one query on average costs 6%, 7%. So 100% you can only write 15 questions, 16 conversations with Fable. So very, very limited. So be careful about what you ask. Be accurate and precise. After this, I'm gonna test on my Xcode. It's always a good idea to test. Let me see if my watch is on the same Wi-Fi. It wasn't charging last night. Okay, it is on the same watch. Yeah, so when you test it on your real watch, you need to check the top bar of Xcode, and you need to pick your own devices. If you pick one of the simulators, it will just open the simulator. But I do want it to be on my own device, but we're still waiting for the code. Usually, when I was using Sonnet and Opus for the same workstream, the same project and same task, it would take much less. Maybe fast task only like 1 to 2 minutes, slow task maybe 4 or 5 minutes. Occasionally it will go beyond 7 minutes or even 9 minutes, but Fable is consistently much slower. On average, I'm seeing each coding task at this stage will take at least 5-6 minutes, if not 10 minutes. So that's something to be aware of. Right, so since the code is ready, so let me start on my phone. Yeah, and on the left you will see the logs, but for this task there is nothing to log. Where is the app? Okay, so because I'm not wearing it on my wrist, no real signal yet. I will just double click to manual start. Okay, so let me see if I can show this to you. If you don't have any signal, it will say collecting ppm, And then now if I just double click, it will show the new tile. Can you see? Yeah, the bottom right one is the new one, so that is correct. All right, I like it. Actually, it's working. And I can cancel the intervention. And there is a reason I don't show everything to you, so you can build some curiosity and you can try it by yourself. Okay, so that is working. We can move to the next. What's the next? Let me stop this first. Switch back to plan mode because it's a relatively larger task. Next, let's get back to the main task. How do we utilize the IMU motion signals, especially what we already logged. We summarized that table before, right? So propose a design. My two main questions, one is, do we still want to keep the old core motion? So we combine the core motion API with the IMU, or we want to drop the old core motion completely and merely rely on the new IMU motion signals. That's my first question. And then my second question is, how would you design the gating logic? Which signal or signals, which subset of the IMU motion signals you want to use, and how would you devise the new threshold? How would you validate and test it? Basically, my first question is, do we want to keep the current system, just add another layer, or do we want to remove the old system and just build from scratch for a new one? My instinct, the old motion 10 seconds delay with 20% unknown rate is not very useful. My instinct is to drop it, but let's see how it is. My second question is more interesting. That is how to design the new gate. It's not straightforward because in the old world, it's very easy. I mean, the logic is very straightforward since we already have the classified motion signal from the core motion API. So either you are walking or running or cycling or driving or stationary. And based on each state, logically it's very simple, right? So you just describe, like if the user is walking or running, then we mute it. If they're sitting still, then we nudge. But the new system is one level lower, right? So it's closer to the raw IMU signal. So it doesn't have these real life meanings yet, not that much. So we need to build this layer. We need to collectively transform a bunch of low-level physical IMU signals into a more meaningful real-time scenario metric and use that to gate our detection logic. That is the challenge for this design. I feel my token is running away. 44%. To be honest, it is not an easy task without real data. If you have real data, you can train. Like you can, based on the label, based on the false positives, we can learn the feature importance. We can rank it and then we can cut. But now, because it's in beta mode, because it's in beta mode, we don't have much data, so it's intrusion call. Which one to use, like which signals to use, and how to threshold them. And do we want a single threshold for each signal, or do we want to transform the signal into a compound metric and have a global threshold on that? So a lot of design choices or questions. I'm curious what AI says. If I recall, the very first IMU signal is the IMU magnitude, and the second is the variance. In fact, even if we only have the magnitude, that is good enough, because the magnitude itself reflects how intensively the user is moving, or like how intense is his current physical state. So say that while we detected the sudden spike on heart rate, if the user's IMU magnitude stays roughly the same as before, like the past 30 minutes baseline, how do we compute this baseline is another design choice, but that's secondary. We'll come to that. If that's the case, then it means it's a real scenario, like it's a heart rate spike caused by internal state change while the user is stationary, and in that case we should capture. Versus if the magnitude also has a spike, that means it's probably a sudden physical movement which drives both the IMU and HR. So in that case, according to the new stating, it is a false positive and we should drop it. I think that's the cleanest way to design it. But let's see. For the variance, it's trickier because I don't know on which period it's calculated and on which sampling rate, because IMU itself on Apple Watch has up to 100 Hertz, so 100 samples per second. That's a lot. And I strongly believe at some point we already downsampled it, but to which frequency I don't remember. So for such a high frequency accurate signal, how much we downsample strongly determine like the data signal loss and the variance change range. So we need to be careful about that. All right, it's ready, but it didn't let me to scroll up. Okay, let me read it. MVP's dominant false positive class is the motion causation spike that the current gate misses. Because the current gate has a 10 seconds delay for the motion, the co-motion classifier. That's true. Scenario matrix inspect doc, set up the products rule. Notify only if and only if the HRS is unexplained by observable context. And reassign posture transition and walking spikes to a motion gate. So we sampled it at 10 Hertz. are already computed. Yes, we already computed and logged it. Always on full access. So the gate is a new consumer of the existing signals. Zero new sensor or battery cost. That's great news, isn't it? Keep both, rescope. Activity classifier is denoted to one course. It is uniquely good at. Demoted. Only reliable detector of automotive. A car risk can be nearly still. Keep suppressing in vehicles. That's another product question, because sometimes when I was driving, I do feel I can do a breathing exercise. We can discuss this later. Yes. Gate design. Here. I just need to. The gate design. If the variance is too large, that means it's in physical movement, then we mute it. Gate close. Live cadence. Oh, so this is for the steps, like the steps per minute. Third one is from the vehicle, the driving case. Do not suppress on missing data. That makes sense. Gate ensures the gate consumes the logged statistics. The gate reads the same 10 seconds window. Whereas that is stamped on the HR row. That's totally fine. Yeah, it doesn't work to have another one. Yeah, mostly good. We do have some past logs. It's only from me, but we still have some logs. So to study the data is the right call. And suppression, we want to log it. That's okay too. So we can also just choose to replace the current detection logic. So but the current detection logic is only for the heart rate, so it makes sense to decouple those. So have some logging would be nice. This we can revise later. I'm not too picky on the actual implementation. These are the dirty details we can leave to the AI. Implementation shape to long didn't read. Yeah, these are the work we should handle to the AI. Overall, it's good. I have a few questions. Overall, it's a very good structure, so thank you. A few clarification questions. Number one is on the 3 gates you mentioned, the 3 suppressed logic. The first one you mentioned to use the variance clause. Why do you choose the variance instead of the magnitude? Or why don't you do both? And the second question is about the you mentioned the gate reads the same 10 seconds window variance that is stamped on every HR row. I assume every HR sample is once per 5 seconds, and we already have the variance log there, so we can read from there, which is good. I agree that's the right choice. Can you remind me what's the 10 seconds? Is this the 10 seconds pass window we looked at to compute the IMU variance? And during that 10 seconds window, what's the sample frequency? So how many total data points we have? And my third question is about deriving the threshold from data. I agree this is the right direction because we already have many logs. And specifically, what's the mechanism you plan to use in order to derive the threshold from these logs? Can you briefly describe? So overall, I think it's a very clean design. I'm just being extra picky on some nuances. If you trust AI more than I do, like you can just let go. If you see this, you say, oh, like I'm good with it. Just go ahead and code. I feel in this case it's very safe. So I'm only doing this partly for my own thinking process, my own reflection, partly because I know I'm streaming, so I think this will be beneficial for you who are watching this. Meanwhile, let me read this. For this data-driven threshold deriving, the question should be below. Wait, where is my question? Is this revised answer? Like the new UI is a little confusing. This is the old answer, right? So it says keep both. I am a little confused. Where did it answer my new questions? These are my old questions. Oh, so it repeated the same question, but it updates the new answer in line. That's why it's not very readable. I guess that's the theme for the planning mode. If we switch to auto mode, it will be a different reply structure. I see. So variance is the right answer because even the user is sitting still, the magnitude will have fluctuations. So if we only rely on the magnitude, under smooth number acceleration, where we must not suppress. So 10 hertz, 10 seconds, 100 samples. Variance of this will be here. Okay, that's good. I don't need to read follow that. Structure deriving structure from data. Basically, it's trying to identify the true positives and false positives for this specific motion-related detection case, and then it will choose the 95 percentile or 5 percentile of the variance for each case. Yeah, here. Okay, mostly good. Wait. Huh? I missed something. Okay, the design is mostly good for me. One last question is still to challenge you a little bit on the variance usage. So I see why we want to use IMU variance. I'm questioning why do we not consider the magnitude at all, since intuitively magnitude is such a powerful signal, right? When I'm sitting still, the magnitude is like flat, but when I have a sudden movement, I imagine my magnitude will jump to a very high spike, the same as HR. So isn't that more prominent than just looking at the variance of the magnitude? Or why can't we use both? Some Chinese. Okay, so I will just live with it. I think it gets my question, right? Yeah, so I'm totally fine with just using variant because it's AI and I'm paying its token, so I want to push it a little further. And these small moments are what I actually enjoy doing more, because the nuances needs a lot of wisdom to dive into. time is closing. So I need to have lunch and drive to San Jose. I believe 45 minutes, 50 minutes. So let's hurry up. Once this question is clarified, I don't need to interfere anymore. I will just leave it to AI. Right, so after this answer, highly likely we are clear on the design and we can proceed to coding. And then coding might take some time. I wouldn't keep you waiting, so I will go having lunch. I will pause here, I will go have lunch, and then we'll leave AI running. And then after the lunch, I will come back briefly and let's check out the result together. I think it's trying to write Python code to answer my question, which is overkill. But that's fine. It is analyzing my logs to calculate the magnitude and variance in order to answer my comparison question, which is very responsible. I think it's also calculating this. There should. You know what? I would just give it auto, so it doesn't need to prompt me every time. And I believe this data analysis job will burn some token. taking longer than I thought. Yeah, from the output, it's merely analyzing the logs, not even coding. Meanwhile, I should download the new logs for it, right? So in order to do that, you can go to Windows Device and Simulators, and somehow I'm not connected. Yeah, so once you connect, you will see your app here, and you click the dot dot dot, you can download container, and put it here. Once it has the container, the model will be, AI will be smart enough to see what's inside of it and analyze all the logs if necessary. I have a lot more here. Okay, this is taking much longer, so let's wrap up here, and I will come back after lunch. Thank you. Stop recording here. Hello, I'm back. So I promised to finish this. It's a little late when I come back home, but let's finish. We are almost there. So to recap, after the discussion, after analyzing all the logs, what Fable presented me is a very promising rule on top of the IMU accelerator variance to gate those high movement, high arousal false positive. And this is the formula. It gives me 3 out of the last 4 ticks with variance larger than 0.05. And I briefly asked him, like, why you pick this number. He gave me analysis here. Forget about the Chinese. Here, it's 2 directional. So first, for steel row, the variance is extremely low. So it's 2 orders of magnitude, around 2 times 10 to the minus 4. So that cap is totally fine. So the key is on the moving rows. On the moving rows, there are 2 directions contradictory to each other. So if we pick the threshold too high, well, to take a step back, like there are 2 things. One is the true movement, like we were running or walking, and those are the false positives we do want to eliminate. But there is another category which is labeled as desk episodes, which means I'm still pretty much sitting at my desk, but when emotion hits, I have some small movements like wrist movements or gesture, or like I was moving the mouse, and those are not false positive. Like those are exactly the scenarios where we do want to capture, right? And when the threshold is small, we capture more of these, and as we increase the threshold, we capture fewer and fewer. So yeah, so according to this rule, we want to capture more of these. So in this sense, the smaller the threshold, let me think, I might be doing wrong. This is the threshold, so when the actual variance is larger than this, we will mute it. So the smaller the threshold, the more cases we mute. Yeah, so if we set t too small, then we will mute most of these valid desk episodes. So that's not what we want. So according to this rule, the higher the better. The higher the t, the better. But the other side is the true, like the real false positive. In the sense, the user is really working or running, and we want to capture those. And for this one, the lower the better, right? So the lower the key, the lower the t, the threshold, the more false positive we capture. So in this case, the lower the better, right? So then the problem comes to how do we pick a sweet spot? So the AI's pick is 0.05. So in that case, we only miss one sample from the true desktop episodes. And for the moving row, we still capture 27%. So we do miss 73%. We do capture 27%. So my question is, yeah, so one looks fine, but 27% seems too low. Then AI told me that, did I ask? Okay, so the AI says so, like the 27% catch rate might be too low, but note this is only for the variance. If we combine this with the cadence with the step per minute, then the coverage rate will be, like the catch rate will be much higher. So I ask it to present the data, the table. So it did. So basically, when we add the cadence data combined with the IMU variance, then overall the threshold T of 0.05 can capture 83% of moving rows. So that answers my concern. So I have no concern going forward. And I asked him to briefly repeat the design so we know what it's actually going to build. The gate in one rule, when a heart rate anomaly fires, suppress the nudge if and only if any of the three conditions or clauses satisfies. The first is the variance clause, that is 3 out of the last 4 HR tick readings of the logged 10-second window variance exceeds 0.05. The second is the cadence. If live cadence is larger than 0, which means the user is walking, then we will mute it. And the last one is the vehicle case. If the user is driving, this is coming from the old core motion classifier, which has a roughly 10 to 20 seconds delay, but in the driving scenario, 10 seconds is nothing, right? We usually drive for at least 5 or 10 minutes. So this is good. fail open throughout means if we have null or missing input data, we won't suppress. So the default is to pass. So pass means we will let the anomaly detection kick in. This is where it lives. Motion gate component, separate component with separate test. I think this is the right thing to do. The only thing I want to confirm is the logging part. How about logging? If HR spikes, passes a threshold, but the gate returns false, so we're going to suppress it. How do we log it and where do we log? What are the design options, in fact? This is another thing that I do not have to ask, right? So I can just let it go, but I think it's better to clarify, because to me, my mental model is there are two designs. One is we can redefine the detection criteria. Like previously, the detection criteria is only on HR. Now the detection criteria is the HR plus the gate, where the gate has 3 OR clauses, right? So we can, if we redesign or redefine the detection formula, then we don't have to log at all. Or the log will be associated with each detection, right? When we detected each anomaly, we log if it's triggered by HR or the gate. If it's triggered by the gate, then which component or which clause of the 3 gate components triggered it, right? So that's one mind model. The second one is to treat the detection as a two-stage thing, right? So the first stage is always based on HR spike. That one remains as is, so we didn't change anything, so we didn't need any logging for that. And only the second part, which is the gating logic, we just add it. And that's where the suppression happens, so we will add the suppression logic, and that's also where the logging happens, so we'll add the suppression gate logs. So these are two different designs. Based on the current state, option B might be the minimum work, more natural. Option A is structurally more generic and future-proofing, but it needs more refactoring of the current code. So I'm fine with either, but I just want to be clear if the AI is on the same page. Context event. That's reusing the event log, which is natural. Option 2 is a parole field. Parole field on HR series. Stamp the gate's verdict on every tick. This is unnecessary. We only need this for detection. A synthetic suppressed episode. Suppressed. Oh, like that's overkill. Wait, why do we need a hybrid? Parole verdict is the continuous record that makes the gate's behavior auditable and returnable from tester data without simulation. I see, so it's mostly for sanity check and reproductivity learning purposes, and the cost is one extra signal, one extra boolean per HR sample, which is once per 5 seconds. I think that's marginal storage. So yeah, so 1 plus 2 is good. So the AI is not on the same page with me, or not on the same layer with me, because it's not even considering redefining. Should I ask it? Or should I just let go? Am I too obsessed with myself? Should I drop off some of my ego? I think I should clarify, because in the future we might have more signals in the components, so the detection logic will be more and more complex. It's better to at least think about that factor now. So here we are still defining the detection trigger as the HR spike and treating the gating logic as a independent orthogonal suppression stage. So I'm thinking the alternative is to view the HR and the 3 clauses in the gate as a redefinition of the whole detection formula. So in that case, we should log every component of the detection, including the heart rate spike, right? So I'm raising this. So for the current version, I agree. Like your current assessment is the right way to go. Option 1 or 1 plus 2, that's the right way. But if in the future we have more biometrics signal, so say that we have real-time HR and breathing BPM and HRV, and say that in addition to these 3 clauses, we have more factors, more complicated logic like AND and ORs, and all these form the new detection criteria. So in that case, does it make sense to redefine detection by combining everything together and then have logging for each component, regardless of the biometric trigger or the suppression gate trigger? I don't know if it gets me, but I try to make myself clear. I admit it's a little over engineering. The bottom line is we shouldn't over design for the future. Like the same for meditation, right? Or the spiritual practice, Zen practice. The key is to return to the presence. Logging is the thing to preserve and extend. When breathing BPM and row temperature arrive, go into the particular exactly like the IMU fields did on day 1. Predict feature is totally fine. Sometimes if the cadence is lower, it can be even per episodes or per session data. So we discussed that in the logging category. Oh, like he is actually repeating the 3 category. Replay can tell you what Formula V3 would have done. Only the event tells you what Formula V1 actually did. This is not very accurate. As long as there is no human feedback, then replay is the same as live computation, right? We can always reconstruct one from the other. So those are indifferent, but that's not worth correcting. I agree. We don't have to. We don't have to renew or redesign the architecture here. That's not worth it. Even if we do, I think the current structure, the trigger logic and suppression logic is still a good separation. Like the trigger could be heart rate larger than X, or HRV smaller than Y, or BPM larger than Z, right? So we have a logic there, but the outcome should be one boolean, like to trigger or not. And the suppression logic could be a complex boolean expression. For now we have 3 or, but it could be anything. And then both will have their own logging. Yeah, so for now the episode start itself So if we have a HR spike without suppression, or like which is not suppressed, then which event logs the start of the episodes? If we do have a HR spike which is suppressed by the new gate, what logs the start of the episode? Well, so the episode never started. So who logs the spike of the HR and who logs the suppression logic in your option 1+2 design? Just want to be super clear that we are logging everything. I think it's okay because when we only have the HR spike, no suppression, then the episode start will have the start timestamp. Like that's what everything happens. If it is suppressed, then the suppression will be in the context, will be in the event context. So there we will have the HR, we will have the suppression reason and timestamp and everything. Gate pass. The flow is unchanged from today. Onset block is what logs the spike, yes. Spike fires, gate suppresses. The detector still fires. True. And the suppression happens at the guarding app sessions and normally callback. So the machine sees nothing. No episodes ever existed. That's correct. No gap. True. The logger of this case is the anomaly callback itself at the moment of the suppression. It writes to gate suppress context event, carrying the same core payload an episode onset would have carried. Timestamp HR based on insertion, plus the thing only this worker can know, which clause suppress and okay. The payload symmetry is important. Okay, that is great. Okay, that's clear. We can start coding. And checking usage. It was reset when I was out. I'm sorry. Should be in settings, usage. Oh, it's using it actually used some of my token today. I didn't know. Anyway, it's 66% and 30%, so we should have enough. We'll just wait. This might take a while, so I will take a pause here, and then when it's done, we come back to validate the result on my watch device, and we double check the log. If everything is good, we update the markdown docs and we commit and push. Okay, let's take a pause. See you soon. Hello, this is Lee coming back. As I promised, I wanted to finish the designing and coding. So here we are. So the design was no surprise. So we're just proceeding with implementing different chunks. The first chunk was for the component, and the second was for logging and wiring, so on and so forth. And now everything is done, and I'm in the testing stage. So I had one brief test, and I verified that when I was suddenly standing up, the detection anomaly was effectively muted, so that was great. But after I came back to my desk, I got a nudge, so I was wondering what's wrong, and it confirmed it's working as expected. So that is exactly the long tail case. Like, it's the scenario we explicitly chose to preserving chunk A. See it again, HR still elevated is the surviving use case for the exhausted emoji slot. So everything's working as expected. My last request was to add more logging so I can see the accelerator reading even without any detection events. So that is done. That was done before. In fact, that was done before I sent this. So I'm trying to start Xcode. It seems connection has some problem. We'll check on my phone, making sure it's on the same Wi-Fi. Yeah, my Wi-Fi is not optional. Okay, so it's both on the same Wi-Fi. Trying to connect. Why you're not connecting? Yeah, so I just went through window, devices and simulators, so sometimes it's easier to connect from here. Seems it's connected. Let me close this and reopen. These are the old log, and it's refreshing, starting a new session. Loading, good sign. Okay, that is good. Yeah, so now for each HR row, we see the current heartbeat and the baseline, and we also see the accelerator magnitude variance. When I rest my wrist on my desk, it's pretty small, to the -5, 5th or 4th, 3rd, 4th. So this is pretty still. That's why the gate is pass. Right, so we do want to detect emotions on a relatively stationary setting, so that's why the gate is pass. If I just wave, what happens? If I wave, at first it comes to 8 to the -2. This is also pass. Why this is pass? Okay, then I have some gating, but the gating happens because of the steps. It thought I'm walking, so it thought I'm walking very fast. So our second clause is gating by SPM. So these are being gated, but even for this 0.1 variance, we are passing, right? So we have to exceed 0.5 if we want to trigger the variance-based gating logic. I don't think I can even hit there. So I stand up and walk, roll. So hopefully my heartbeat will come up. And let's see what happens. Activity running, right? So this has every reason to gate. This has every reason to gate. Variance 4 in a row, larger than the threshold, and SPM is large and motion detector detects running. Every reason to gate suppress. So I have notification on my phone, which is great. How about the long tail? Now the gate passed, but because the session was long, so the baseline already rose to catch up, and the recovering heartbeat is just 13-ish higher than that. I believe it's marginal on the 3 sigma, so that didn't trigger. And then now the baseline catch up even more, so it has no chance to catch up. Yeah, so I think everything's working as expected, so we can commit and push. I don't need to copy and paste. I think this is already clean. Okay, great. Everything is working. So update all the MD docs, git, commit, and push everything. By the way, my first query today cost me 26% of my session quota, which is crazy. So I cleaned up the context. I ran slash compact. So even after that, a very simple query cost 7%. So I believe Claude definitely rose the spending speed for Fable for the past few days. Oh, we have to accept it because the big models these days are like the commodities, right? So we're the consumers, so we pay the price. And also today is July the 10th. According to the official announcement, Fable will be off the monthly plan. The last day will be July the 12th. So excluding today, I have 2 more days. After that, we'll figure out whether we continue by burning API, or we just live with Sonnet or Opus, or we always have Gemini and ChatGPT. We'll see. Alright, this is the boring part. I don't think it's worth waiting for it just to show you like the success message on the successful git push. So I will end early here. Again, I'm Lee from Starlia, and thank you for watching. Until next time.